welcome back, grade 9s. This is part 2, or the second lesson we're going to look at, and we're going to look at something new called a chord. So last time we looked at tangent lines, which touch a circle in only one spot. This time we're going to look at something called a chord, and that's a situation where a line joins 2 points on your circle. So I've got 3 examples of chords that are available to you. There's this red one, and that one is connecting this point and this point, and because it only connects 2 points, that is going to be a chord. There's this blue one on the far end of the picture. It's also connecting 2 points, which means that that's also a chord. And the last one is what we call the diameter. Diameter is the longest possible chord that you can have on a circle, and it splits it perfectly in half. So the 2 furthest points on a circle, when they're connected to each other, we call that the diameter. And that's important to us for a couple of reasons. One of them, which you might already recognize, is that half of the diameter ends up being your radius. So if you have 2 radii that are perfectly joined together, you might end up having a diameter, which means you also have a chord, the longest chord. Now, an interesting thing that happens when a chord is parallel to your diameter is you can draw a straight line that bisects that smaller chord. When you do that, that line is called a perpendicular bisector. So that's how you spell it on the end there. It's a fancy word for saying that it is a line that is perpendicular to your chord, so it's going in the complete opposite direction. And something interesting about perpendicular lines is that when they cross, they create 90-degree angles. Because it's a bisector, it also means that you are splitting your line perfectly in half. So whatever the distance of this line was, if you split that number in half, 1/2 goes on the bottom, 1/2 goes on the top. Sometimes you won't be given the full distance, you'll only be given half the distance. But if you recognize you're working with a perpendicular bisector, it means that whatever number you have for, say, the bottom half will be the same number you have for the top half. So you might be wondering why I didn't draw a perpendicular bisector to my red line. Well, I could draw a line that splits it perfectly in half from the origin, and I'd have another perpendicular bisector in this direction. You can go in whichever way you want. It's always fair game, but in this case, I've just chosen to use the blue line for the example. So what does a chord problem end up looking like? Like that. I might ask you to find me the length of CD. CD is a chord you can see on the bottom, but this is the only information that I've given you. So you need to use all of your understanding of both triangles, angles, circles, to try and figure out what that length might end up being. There's a few pieces of information that you can gather from that. We know that this angle here at E, so from OED, ends up being a 90-degree angle, which means that we have a perpendicular bisector. If that's true, it means that this angle is also 90 degrees, and both of these lines are going to be the same length. I don't have to give that to you. You recognize that because you recognize you have a perpendicular bisector. You also notice that my diameter is 26 centimeters, which means that my radius would end up being half of that, which is 13 centimeters. So this half would be 13, this half would be 13. And so this is where thinking outside of the box, which I mentioned previously, comes into play with circles. You don't have any more information, but you can use the information that you do have to make this a more workable problem. The key is that you recognize your radius is 13 centimeters. If you know that, you can draw a line anywhere you want, and as long as that line goes from your origin to the outside of the circle, you end up having another radius. You end up having another line that's 13 centimeters long. Not only that, you've created a shape that you can work with. This is a triangle. You know that you could use Pythagoras. A squared plus b squared is equal to c squared. C has to be your longest length. So in this case, 13 is my longest length. It has to be opposite of your 90-degree angle. That's true. So this bottom side can be A, this 10 can be B, and I could solve for side A. And the math looks like this. I set up Pythagoras, a squared plus b squared equals c squared. I substitute in a number for b, a number for c. Rearrange my equation. Once I've solved that, I end up getting a squared is equal to 69. Square root of 69 will give me the a value, which is 8.31, or it's approximately 8.31, because I end up being a little bit of a longer decimal. Because I know that now, because this was my A side, this ends up becoming my 8.31 centimeters. I was looking for C to D. I've only found C to E, but I recognize that because I had a perpendicular bisector, C to E is the same length as E to D. And if I'm looking for C to D, I can add both of those numbers together. That ends up giving me 16.62 centimeters, or approximately 16.62 centimeters. That's a chord problem. I'm going to give you a practice sheet where you can work on stuff like this one. Again, if you're following your rules, things can work out pretty nicely. If you need to take a step back and take a look at some of your rules, it might take some time to get through it, but the logic always works with circle problems.